Hi, so welcome to chapter 10. In this chapter, we're going to talk about electricity. And there's a lot of information packed in this chapter. I guess that's the case for a lot of the chapters that we go over. In this first video, the goal is to define electric charge. And that's an extremely important concept for this chapter because it's really the base of everything that's coming next. So make sure to pay attention. This is really going to be the base for what's coming, just like when we studied, gravitational force, we had to define inertia and mass. And this electric charge would be a little bit the equivalent of mass here. But in a new context, we're going to study a new force. We're going to look at the electric force. We'll see that it's an interaction. It's due to the interactions between charges. Before we can get to that, we have to figure out what an electric charge is. So first of all, how do you recognize an electric charge when it's mentioned? Usually the symbol for that is going to be a Q. Sometimes we need to show two different charges, so you'll see a little q for a smaller one, or a capital Q for a larger charge. All right, so usually it's given with the letter Q. Sometimes you'll have Q1, Q2. So any object is going to have a charge, just like it's going to have a mass, a temperature. So to define an object, you can measure its charge. So that's a property of a given object. So unlike mass, which is something that is always positive, as it turns out, the electric charge can be positive or negative. And so you may already know about some objects that are positively or negatively charged. So we have some examples here. If you look at the structure of an atom, in the nucleus, we have protons, and we know that protons are positively charged, so they carry a positive charge. And as part of our atom, we also have electrons, and electrons are negative charge carriers. Okay, and it's possible that we have objects that have a charge that amounts to 0. And in that case, we would say that they are neutral. All right. So what's new here, and that's going to contribute to some complications for us, and like what we had for gravitational force, is that this charge can be positive or negative. All right. So units of charge. So this is something brand new that we have not seen before. We're going to measure our charge in coulombs. And the symbol for that is going to be capital C. You'll see that the charges that we'll look at are typically very small. So don't be surprised if you see something like a microcoulomb, for example. Microcoulomb, that would be 10 to the negative 6 coulomb. All right, so you would divide by 1 million. A very important property of charge is that it is a conserved quantity. What we'll see is that objects can exchange charge. So we're going to see that our charge carriers, so for example, our electrons, can be picked up from an object and going on to another. But what is important is that even though there can be a transfer of charge, charge is always going to be conserved. So it will go from one place to another, but it's not going to just disappear, okay? It's not going to also appear out of thin air. So that means that if you have an amount of charge in your system when you start, whatever happens, within the system, it could be that you completely change distribution. All right, so in your system you had 3 objects, and Initially, all the charge was on one object, and then by the end of whatever you did, you have charges everywhere. Um, if you look at the total amount of charge, it will still be the same. All right, it's not going to be created nor destroyed. All right, so that's something very important. So what we're going to do next is take this concept and actually really very much apply what we've learned from the gravitational force and see how it's going to apply to these charges. So we know that when we add two masses, all right, we have a an attractive force between the two, and when we have two charges, what is going to happen? How do we measure the force between these charges, and how do these interactions look? Because now we have to be careful, because do we get the same thing when we have two positive charges, two negative charges, one positive, one negative? So we have more scenarios that are possible, and that's what we'll talk about in the next video. All right, thanks.